In animal production, we make decisions based on what we see, but some key processes aren't directly visible. This is where AI comes in. It brings those hidden processes into view. In nutrition, how do we really know which amino acids are limiting in our animals? We often assume fixed priorities, lysine first, then threonine, then others. But are these priorities truly universal across all conditions and production systems? Maybe not. Let's look at an example of how AI can help identify limiting nutrients in broiler chickens. We took the data from this study and reanalyzed it with AI to identify patterns. In this experiment, 8 diets were evaluated. Across these diets, amino acid inclusion levels varied. For example, leucine changed from one diet to another, creating a distinct pattern of inclusion. Each essential amino acid had its own pattern. Here, we show only 4 as a reference. Now, when we compare these patterns to the weight gain response, we find that histidine most closely matches the growth response. This suggests that histidine had the strongest influence on growth. In other words, under these conditions, histidine behaved as the first limiting amino acid. So the next question is, how much histidine do we need? Using this same dataset, the analysis estimates an optimal level of about 5.3 grams per kilogram of diet to improve growth. For more precise recommendations, a targeted follow-up experiment would be needed. In this analysis, histidine emerged as the first limiting amino acid, followed by isoleucine and leucine. In the original publication, these amino acids were not flagged as having a strong effect on performance. From a practical perspective, key nutritional limitations may go unnoticed, so diets meet requirements but still limit performance. Now, let's look at a second example in gestating sows. In this study, 4 experimental diets were provided during late gestation, each with different amino acid inclusion levels. When we analyze stillborn piglets, hydroxyproline shows the closest match to this pattern. Hydroxyproline emerges as the main driver of stillbirths and can be interpreted as the first limiting amino acid for this trait. This is important because traditional approaches to identifying limiting amino acids cannot even conceptually consider non-essential amino acids as limiting. Using AI for pattern recognition allows us to detect limitations that previous conceptual models simply cannot capture. For more information on the use of AI in animal nutrition and production, visit animalsciencedatalab.com. This work is part of the Livestock Sustainability Group at the University of Minnesota. Thank you for watching.